Question 1. What are the 5 assumptions to check in order to do inference for simple linear regression? How do we check for them? And answer these questions by filling in the following chart. Okay, I recommend following along with this video with the worked solutions page open. I'll be reviewing what's already been written there. Okay, so the first assumption is that there is a linear relationship between x and y. Okay, the reason for this is if we get our data and the data points are just all over the place, then trying to fit a line to describe this will be useless. Okay, so the first thing is the requirement is that the data has to appear in a linear formation. So it's got to look like it's in some kind of line. Okay. The second is that the error term epsilon is normally distributed. Okay, so we can do that by doing a QQ plot of our residuals. The residuals can be found on your Excel sheet in the top left-hand corner. Okay, so your residuals, you can copy and paste those and then drag them into the first Excel sheet that we worked with. And when you put them into your QQ plot, they should be pretty linear. Okay. The third is that the variance of the error terms is constant for all values of x. Okay? So on this one, we're going to graph a residuals plot. And you can graph a residuals plot, and then on your residual plot, you want it to be completely random. Okay, centered around this being 0, because you want half of your data to be below the residual line, correct, or the trend line, and half to be above. If you see something that looks like this, where there's a lot here and then it gets smaller and smaller down there, we call that a megaphone shape. Okay, and that's bad. That means if that comes up in your residual plot, then your data is not, so you don't pass that assumption. Okay, and then the final two, the x's are fixed, measured without error, and the observations are independent, are things that we can't check for, but we assume that was taking place during the collection of the data. Question 2, in the formula y equals b0 plus b1 times x plus epsilon, state what each symbol stands for. Okay, so here is our classic equation, b0 plus b1x plus epsilon. Okay, for our linear regression model. Now we're going to review real quick what these mean. So your y is representative of the response variable. Okay, so that's what you're trying to predict is the y. The b0 is your y-intercept. Your b1, remember, is your slope. And then the e, the little e, which is the Greek symbol epsilon, is your error. Okay, the common error, which is just a normal random variable. Okay, and that is your linear regression equation. So we're going to check the 5 assumptions for conducting a linear regression on the data. A. The first is that there is a linear relationship between x and y. Okay, so I've already copied and pasted the x and the y's in, x being our head length, y being our body length. And Excel produces this scatter plot for us already right here in the bottom middle of our sheet. And because the data points form a positive line here, we know that there is a linear relationship, so we can pass the first assumption. B, the second assumption, is that the error term epsilon is normally distributed. So in order to do that, we're going to take our residuals and we're going to drop them into our QQ plot, which remember can be found in the quantitative descriptive statistics sheet. Okay, so we're going to come over and first we can clear the contents of what's in there. And then we're going to paste. Oh, looks like it didn't grab it. So we can come back here, grab the residuals, copy the residuals, and paste F to there. Okay, so remember, if it ever comes up with this, then you just need to copy the, or you need to paste the values. Okay? And then just also remember to put them in ascending order. Okay? And then there you have a QQ plot. And we can see that our QQ plot is linear, which means we pass our assumption. So don't forget to paste that into your word. The part C, or assumption C, the variance of the error terms is constant for all values of x and y. There is no megaphone shape in the residual plot. Okay, so now we're going to come back over to our normal quantitative inference procedure sheet. And we're going to take our residuals and we're going to make a different scatter plot. So we're going to come up here to insert, scatter, just a regular scatter plot. Okay, so did you see how I did that? So I just highlight the data that you want, which in this case is the residual. Come up here to insert, and then insert a scatter. Okay, and we can see this. So we have so this is our scatter plot. So we can copy and paste that in, and we don't see the megaphone shape, meaning that we have highs and we have lows here. So we're good there. Assumptions D and E are that x's are fixed and measured without error. We cannot tell just with the data that we've given. We're going to assume that those that collected the data collected the data in the appropriate manner. Question 2. Test if there is a linear relationship between head length and body length. Okay, so our null and alternative hypothesis are that B1 and B1 is equal to 0 would be our null hypothesis. And the reason that's the null hypothesis is that our slope is 0. Now if you can imagine a slope of 0, that would look like a scatter plot. There's just dots all over the place, and there's no relationship. But our null, or our alternative hypothesis suggests that there actually is a slope to the line. Part B says let alpha equal 0.05. Part C, state the test statistic and value of test statistic. Okay, so the test statistic is down here, and that is the t-score. Okay, and remember it's the t-score of the slope, because that's what our null, that's what our hypothesis is working with. We're wondering about the slope of the line. So our test statistic is is 22.675. Question D, based on the p-value, do you reject or fail to reject the null? Well, our p-value is extremely low here. We found it to be just negative 12 zeros, or 12 zeros and then a 5, so very small, so we definitely reject the null. Part E, state your conclusion. Well, we have sufficient evidence because we rejected the null, and then we're going to restate our alternative hypothesis, which is to suggest that there is a linear relationship between the head length and the body length of the gharial crocodiles. Or in other words, that the slope is not 0. And it's pretty obvious here that the slope is not 0. Question 3. Create a 95% confidence interval for the true slope of the regression line relating head length and body length. Okay, so the confidence interval can be found right there. And this confidence interval is describing we are 95% confident that the true slope of the line is between these two values, between 6.7 and 8.1. Check the 5 assumptions for conducting a linear regression on the line, or on the data. Okay, so the first assumption we're going to check is that there is a linear relationship between x and y. Okay, so in order to do that, we need to graph it, graph our data. So we're going to go to Graphs, Legacy, and Scatter Data. Simple scatter plot will do. We're going to move our body into the y-axis because that's what we're trying to predict, the body length, and our head length into the x-axis because that's what's given. Okay, we have it right here. And it appears that yes, in fact, there is a linear relationship. So that first assumption is passed. The second is that the error term epsilon is normally distributed. Okay, so we can do that by making a QQ plot of the residuals. Now, before we make a QQ plot of the residuals, we have to find the residuals. So what we're going to do first is go to Analyze, and then Regression, Linear. Okay, here again, our independent is head, and our dependent is body. We're going to come over to Save, and we want the unstandardized residuals, because that's going to plot a new variable for us. Okay. So then if we come back over to our data, we have our residuals here. Now, in order to make a QQ plot, if you remember, we go to Analyze, Descriptive Statistics, and Explore. And we want to explore the unstandardized, there they are, into dependent, and then our, let's see, I've got to make sure it's a plot, and we want to plot the normality. Okay, and continue, hit OK, and our QQ plot shows up right here. Okay, and we can see that that hovers right around the line, very linear, so our second assumption is passed as well. Part C, the variance of the error terms is constant for all values of x and y. Okay, so this time we're going to find a plot of the residuals. Okay, so we come back to our data, and here on our data we're going to graph legacy. We're going to do another scatter plot, another simple scatter. Okay, we have our head and our body length already in there, but we want to take the body out and replace it with the residuals. Okay, and then we keep our head length in the x-axis. Hit OK. And sure enough, there is our residual, with this being the 0 line right here. So we don't have any kind of megaton. It's all scattered pretty evenly. Parts D and E, or assumptions D and E, meaning x is our fixed and measured without error, and that the observations are independent, we will just assume to be true, that those collecting the data did so when they collected the data. Question 2. Test if there is a linear relationship between head length and body length. Okay, part A, state the null and alternative hypothesis. So the null hypothesis is that the beta 1 or the B1 is equal to 0, meaning that our slope is 0. And if you can notice right here, this is an example of something that would produce a slope of 0. See, if you were trying to draw a line in here, a trend line, it would be pretty flat because there's just about as many below and above across the whole thing. So our null hypothesis is that there is no slope. However, our alternative hypothesis is that B1 does not equal 0, that there is in fact a slope. B, let alpha equal 0.05. C, state the test statistic and value of the test statistic. Okay, so the value of the test statistic can be found right as we go back to our data. Okay, and this time we're going to need to analyze the regression linear again. Okay, we have our everything in its right position, and we hit OK. And the data that it pulls out, oh, here we go. Here is the table that we want to use, the coefficients. Okay? Because remember, in an equation, the coefficients are the numbers that go before the variables. So our head length is the slope, which is what our hypothesis test was concerned with. So we're going to use this second row here. And we know that it's already 7.4. And we can find that our test statistic is 22.675, given right here as a t statistic. Part D, based on the p-value. Okay, so our p-value is 0.00. Okay, and with that 0.00, we know that it's obviously not 0, but it's a number that's very, very small. So since it's less than 0.05 alpha level, we know we can reject the null, because since p is low, we reject the null. E, state your conclusion. Well, we know that we have sufficient evidence because we rejected the null, and then we're going to need to restate our alternative hypothesis in words, which was that there is, in fact, a linear relationship between the length, the head length, and the body length. Question 3, create a 95% confidence interval of the regression line relating head length and body length. Okay, so the 95% confidence interval for the true slope of this line is somewhere between the 6.7 and the 8.09. Okay, so we need to, looks like we didn't check that box beforehand, so let's just run through that again. So we come over to analyze regression linear. Okay, and under statistics, we want to make sure we include the confidence interval, make sure it's at 95%. Okay, and there it is. Okay, so our confidence interval is between 6.7 and 8.1.